data frame. Okay, so scalar. So scalar is just a single element where you can assign only one value to a one variable. Okay, so it can be like a equal to 2, 3 equal to sorry, it should be number. The value should be assigned to a variable. Okay, so the variable should always be a alphabet or a collection of alphabet. So this scalar can be a number as well as it can be a string or a character, or it can be logical. Okay, so here we have assigned x equal to 5, so which is a scalar. Okay, whereas in a vector it's actually a collection of scalars, so where you'll be having a quantity as well as the direction of the value. Okay, so it's just nothing but a sequence of numbers. Okay, so here you have x is equal to 354, so which is kind of like in listed in a concatenate. Okay, it's kind of concatenate together. Okay, so that's why you have c together. Okay, so yeah, we can like I can show this in the our screen. Okay, see, I have for a vector I have just assigned x equal to 354. When I run it, it gets assigned here, and then the class of x. To find out what is the class, you can just identify or give class of x. It's numeric. Actually, there are 5 different types of classes a vector can have. Okay, so first one is logical. Vector can be logical. I mean, which means you can have a true, false, a collection of true, false inside a vector, and then it can be integer. It can be a real number. It can be a complex number, or it can be character. So I think you all know what is a real number, complex number. So you have natural numbers, which is subset of whole numbers. Whole numbers is a subset of integers, whereas integers is a subset of rational numbers. So both rational and irrational numbers we form a. I mean, real numbers are formed, but complex numbers are kind of imaginary numbers, which is not part of real numbers. Okay, so which is in the format of you can say 3i plus 2. So here the I value is I square value is equal to -1. Okay, since you will not get I square equal to -1 in any it's not possible, right, for a real number to have this. That's why it is called as imaginary numbers as well. So to know more about complex number, I'm just like giving you a video link for Khan Academy, so you can just like go and like know more about, explore about complex numbers if you really want. Okay, so but we'll be like dealing with all these 3 basic vector types. Okay, to know the vector type of your vector, you can just like give class of the vector name, variable name. Okay, so I can like show it here by running it. So here it's numeric because we just have numbers. So here I have O is a concatenate of Adil, Deena, Kamalesh, Satish. It's just a list of list of names. So I'm assigning it to O. So the class here is character. Okay. Here also cat and dog is assigned to Y, which is the character again. I have cat and 5. So it's really possible to assign both a number as well as a string to a variable in list. Sorry, in a vector as well as in list. It's possible. We'll see that later. So here the class will be character. So here the number 5 will be turned into a character. So when you print the class, it's going to be a character. Okay. So I have q equal to 0.1 and 2. So here we already have a assigned this checked out whether it is a numeric or not already, but still I'm running it. It's numeric again. Okay, so here I have r is equal to concatenate of 250 cat. Okay, so I have a logical value true, 50 and cat. Okay, when you have logical values with the numeric with a new string, so it will be like identified as a string only. Okay. So here I have s is equal to true, false, and true. Okay. So the class is actually logical, that we all know. Okay, so it's also like possible to convert from one vector type, I mean one class to a other class. Okay, let's see how we do that. Okay, so you have p is, from 0 to 5. So here class is numeric, so we are trying to convert this numeric into a character. So for that you are using a function as dot character. So when you give that, it will be converted into numeric, so you'll be having a double quotation. So always when you have our string, you have double quotation. You see here we had cat, right? So cat, we have double quotation. So when you have when you have words within double quotation, it's actually considered as a string. So I'm just like converting this into character. When you print it, I have 0 within double quotation, which means though it is a number, it has been treated as a character. Okay, so you can't do any computation, you can't do any arithmetic operations, that you can't just add t1 with any of the other numbers. Okay, we can also convert that to logical. So when you convert that logical, only 0 will be treated as false, the rest of the numbers will be treated as true. So we'll see that. So I'm like converting to logical. So here 0 is being treated to false. Okay, so I'm assigning some complex numbers, a equal to 2 comma 3i, 2 plus 3i comma 2 minus 3i, 5 plus 0i, and then I'm checking the class, it's complex. I have a combination of both complex and a string. Okay, so here it will be a character only, because this will be this complex number, like any other number, will be treated as a character. Okay, so when you have true and dog, which is like logical as well as character string, it will be considered as a character. Okay, so next we'll be looking into list. Okay, wait, so list is actually a special case of vectors. So you will be having a different elements, and different elements can be a different class. Okay, which is also like possible for vectors. But you, for example, you have cat and dog, you will be like this cat, dog, and true. The true will be like this, which is a logical value, which will always be considered as a string. But in this case of a list, it will be treated as a logical value itself, which means you can have different classes within a list. Okay, but you don't have to define and combine together as a single class. Okay, so and also you can have one different list within a list. Okay, so you can use vectors. For example, you will understand this only when you get into matrix. For example, you have two different vectors, and when you combine that, you can form a matrix. Okay, but these two vectors can be of the same length to form a matrix. But if even if the vectors are like of different lengths, you can form a list. It's possible with a list, but not possible with a matrix. That's, it's very important. Even it has been like kind of asked in interviews as well, what is the difference between list and a matrix? Okay, so you can just say that you can just bind vectors to form list as well as matrix, but for list you should have it, you can have different length, but for matrix you should have the same length of vectors to form a matrix. Okay, here in matrix it should be only numeric, but whereas in list it can be a string, or it can be logical values, it can be anything. Okay, it can contain different elements, it can contain different elements of different class, and the class of the list is list. Okay, here is an example. So you have list 1 equal to list of 1 comma 2 comma a comma 2 plus 3i. So, and you can also like list two variables within a list. Okay, we can just see this in R. Okay, the same thing that I've showed you earlier. Character class of list one is list. So imagine we can like form two variables, have two variables of different what do you say, different classes. We can combine together to form a list. So we already had used x, right? So x was 3, 5, 4, and y was cat and dog. I can like combine this x and y to form a list. This x and y we have used earlier, remember, in a previous session. Okay, so the list 2 is list of x comma y. Okay, the list 2 is when I printed the list of x is list, I mean the x is 3, 5, 4 and cat dog. So this is a different list, this is a different vector. So both gets printed, and the class is list. Whereas when you print a vector of different with different class elements, you will be getting a string here, but whereas here it is a list. Okay, so for example, here I have a temperature of different temperatures here assigned to TEMP, and I have the chance of rain here assigned as logical values, and I'm trying to form a list. Okay, and the class is actually a list. Okay, you can also like form a data frame with this. We will see that later. Okay, so here I have when the temperature was 20, chance of rain is true. I mean, it might rain. At 25 degrees Celsius, it will rain. For 30 degrees Celsius, it will not rain. For 45 degrees Celsius, it will not rain. For 20 degrees Celsius, it will rain. Okay, so that's all about your list. We'll get into matrix right now. So matrix, I think we have all studied matrix in the lower classes. So it's nothing but a rectangular arrangement of elements. So usually you will be having a fixed number of rows and columns. It can be any numbers, which should be like easy to count. It can be 2 comma 2 matrix, it can be 4 comma 2, or 1 comma 1. Yes, it's even possible. I mean, if a matrix has only one element, the dimension is 1 comma 1. Okay, here we have a dimension of 2 comma 4, 2 by 4 matrix here, so which has 2 rows and 4 columns. Okay, so this matrix actually can be formed by combining two or more vectors, but that should be like the number of elements in the vector should be equal to form a matrix, whereas in list it should not be the case. And the class of the vectors and the class also should be numeric. Okay, we can see that in R right now. So we have M1 equal to matrix of 2, 3, 4, 5, 6. So all these vectors is assigned to M1 with 3 rows and 2 columns. So I'm running this and I print it. This has been arranged in 3 rows and 2 columns. N row is equal to 3, N column is equal to 2. Okay. So you can also like do it otherwise. So here I'm giving the same thing, but I'm saying B by row is equal to true, which means you have we are asking the computer or R to arrange the numbers by row. Okay, so here it has been arranged as sorry, I have to print it. It's been arranged as by row. So 2, and it goes to the next row 3, and then it comes to the next row 4. I mean, in the same row, 2, 3 comes, and then the next row 4, 5, and 6, 7. Whereas here, earlier it was like it was printed as 2, 3, 4 continues in a column. It is arranged by column, but here it is arranged by row. Okay, so if you in default by row is false. If you don't give it, it will be arranging the numbers in the column wise. But if you want the computer to arrange it in the row wise, you have to give by row is equal to true. Okay, and you can also like pick out a particular number from your matrix. For example, you want to like identify the first element in your third row. So first you have to give it the row number. So row number is 3, column number is 1. So 3 comma 1 element is 6. For M2, third row, first column, the element is 6 here. Yes. And for M2, second row, second column element is 5. So let's see we get it right. Yeah, we got it right. Okay. We can do any arithmetic operations on matrix that we do in scalar or a vector. Okay, we have two matrices, right? M1 and M2. Let's try to do the addition. Yes, we can do this. So each of the element will be like computed. Either if it is addition, it will be added. If it is subtraction, I mean, we are getting a answer after subtraction. Division is also possible as multiplication. So it's all possible. Okay. Now we'll move into data frame, which is the last data type. We have been discussing about scalar, vector, list, matrix, and finally data frame. So here you're using a tabular form to store your data and visualize your data. Okay, so that is called data frame. So it actually this kind of looks like matrix, but here you can have different columns with different modes, which means you can have either numeric, character, logic. You can have any kind of different modes. Whereas there you will be having only in matrix you'll be having only numeric. Okay, so we were just seeing the weather data, right? We had temp variable which shows the which stores the temperatures, and the rain variable which stores the logical value of whether it's possible of raining or not. So that can be like combined together to form a data frame. Okay, where you can just like combine two variables to form a data frame. Okay, so this is how a data frame looks like. So this is the example of iris data set. So iris data set is kind of collected by measuring the lengths of different iris flowers. Okay, iris is nothing but a flower. So different flowers are measured. Okay, so the sepals are measured, the petals are measured. So for a sepal we have a length and width. For a petal we have a length and width. So there are three different species. There are many species in iris. So we have like, I'm not sure how many species we have. So but in this iris data set there were three different species where of flowers were measured and then stored. So we actually have almost like 150 rows of data of iris data set, and this has been like commonly used for any testing in R. Okay, it's just a common data set that's been used in R and Python. Okay, so we will just like look into R to check how data frames work. For example, we have name, Ajay, Suren, and Tarun. Okay, for age we have 10, 12, and 15. Okay, I'm creating a data frame by combining name and age. So here I'm just like writing data dot frame. Okay, remember that. So it was list for list, matrix for matrix, C for vector, and nothing for scalar. For data frame, it's data dot frame. Okay, so I can just print the df. So I'm getting it in a table format. Okay, 1 to 3 is my row number. So my column name is name and age. Okay, you can also like view it in a table form by giving view of df. So we should be always in uppercase. Remember that most of the people get this wrong. Okay, to view it in the table format, you have to give view df. And I was like talking about iris data set, right? So this is also like kind of inbuilt in R already. So for to see this, you can just check view of iris. Okay, so I told you there are like 150 entries here and 5 columns. Okay, so this you can like sort and then sort according to the ascending order, descending order, and then check it out. Okay, so like that we have empty cards data set also, which is the combination with the data of different cars. Okay, we have the card names and the mpg. Okay, it's a miles that goes per uh, 1 liter of gas, and the cylinder capacity and the display, hp, horsepower, and all these things. So you have like 32 entries of 11 columns. So 32 rows and 11 columns you have. So number of gears, everything we have it here. Okay. Okay, so we kind of like discussed about the data types. Okay, so now we can just like look into what are the different types of operations that we can carry out in this data types. Like what are the operations that we can carry out in list, data frames, and vectors. Okay, so we can just see this right now. So I'm closing all my data frames. Okay. Okay. So, so for example, you have a list of elements and then you want to identify the index of it. Okay, so to find out the index numbers of it, we use grep. Okay, so here you have letters. You know what is letters? It is an inbuilt function, right? It's a alphabet sequence from A to Z in lowercase. So here we are trying to find out the index numbers of the elements from A to K. For that you use grep. Okay, so okay, so until K, the index number it ends with L. Okay, and if you want to find out the value of A to K, okay, so which means you want to print the alphabets. Okay, instead of, so you can just give values equal to true. Okay, so here you're getting ABCs until K. Earlier you didn't get that. Okay, you were just getting only the index. To get the index numbers, you just have to give rep the values and the letters. Okay, when you give value equal to true, you get it. You get the values. So in default, the values is equal to false. Okay, and grep you have grep L. Okay, so when you give grep L, it actually prints the letters. Okay, it actually gives you a list of letters directly. You don't have to go for value equal to true when you use grep. So both gives the same answers. Okay. So we have a small task here. We have a list of numbers ranging from 13 to 54. So here we are trying to identify which number is starting with the 2. Which number is starting with 2. Okay. So for that we can use grepl. Okay. So we used grepl here, right? So you can use the same thing here. So for that you have to use a caret symbol. Okay. So this caret symbol is like used to denote like which is like kind of which is starting, which is always works on the first letter or a first numerical, okay, number. Okay, so when I print it, it says it checks 22. Yes, it starts with true, so we get a logical function true, logical value true, 24 true, 26 true, 65 false, 43 false. So it goes on. So it checks whether the first number starts with true or not. So for that we are using grepl. Okay, so let's see how substitution works. Okay, so we have x is equal to hello. We want to substitute m instead of el. Okay, so for that you have to use sub function. So please understand this, because we will be using all these things when we want to like manipulate your data, or manipulate your data types in the matrix form or list form or a data frame form. Okay, so I'll show you how it is being used in the data frame itself. Okay, so I'm assigning x is equal to hello, and I'm trying to substitute L with EM. So instead of hello, it says hemlo. So only the first L gets substituted with EM. Okay. So for that, I use sub. So you want both the L's to be substituted, you have to use global substitute, which is G sub. The function is G sub here. Okay. So when you give G sub, it becomes hemo. Okay, so to convert, to replace only the first character, you have to use sub. To complete, to do the substitution globally for the whole data set, you have to use gsub. Okay, now we are trying to replace all the h with blank. We have hello and hi assigned to x. So, there are like a lot of different answers is possible. Okay, so when you use g sub, I have hello starts with lowercase h, hi starts with uppercase h. So here, when I use G sub, only the lowercase hello, lowercase h in hello gets substituted. Hi, the uppercase h remains the same. To do that, what I can do is you can either use sub double, both uppercase and lowercase h, and then give a blank. So here, both the lowercase and uppercase h get substituted with blanks. Otherwise, you can use G sub, where you can just give ignore case equal to t. In default, it is false. So here, when you give this ignore case equal to t, you can even use it with G sub. Okay, so it is possible with both sub and G sub. Okay, so there is a data set called trees, like your NP cards and iris, which I've showed you. I'll just show you the trees data set as well. So I have 3 columns: grid, height, and volume. Okay, so I have a total of 31 entries. Okay, which means 31 trees data has been collected by measuring the grid height and volume. Weight of a tree is difficult to calculate, I guess. Okay, so we're trying to replace the maximum value of the trees by 60. Okay, first check. Okay, the volume. We'll just check. We'll try to sort. The minimum value starts with 10, and the maximum value is 77. So we want to like replace this maximum value of 77 with 60. Okay, so I just sorted it right now. I can also like try to find it out for the function max of trees. Trees is the data frame name, volume is the column name. So trees start, $sign volume, the max is 77. You can also like try to find out the minimum. Trees volume. Sorry, you should be always careful about the typo. The minimum is 10.2. You can do this as well. Okay. So I'm trying to like substitute the max of tree volume value with 60 in the trees dataset volumes column. I'm running this and I'm storing it in T2. When I print T2, so here I have 60. Earlier there was no 60, right? The maximum value was 77. Now it is turned to 60. Okay. Okay, so there is a few things that you can do it on character strings. So here you can just like try to paste two words. You can use paste data space sign. Okay, so usually then when you print try to print two strings, you will have a gap blank within. So when you want to separate this with a underscore, you can just give step equal to underscore. So we are using a underscore as a separator, data underscore signs. Okay, and if you want to example, you already like store data underscore signs in the variable x, and you want to split in the when the underscore occurs. So when you do that, so it gets splitted and stored as a list with data and science as two different elements. But when you try to do that with ES, so you have data underscore as one element, science and without S is your another element. Okay. So I have a task here which is also in your PowerPoint, which you have to like do it when after this session. Okay. So I'm just leaving this. Okay. Then we are moving into data exploration, where we'll be like looking into how you can explore data which is in a data frame format. Okay, here you will be using the data iris. So I already like showed how the data iris looks, data frame iris looks. For the to use that, you can just try to like call data iris. Then if you just type data frame name, it gets printed here. But since it's like kind of having 150 rows, so it's difficult to like see it in your console. The best way to like visualize the data frame is like by giving a comment view of the data frame name. Okay, so this is how the data frame looks like, which I've showed you earlier. Okay, so you want to identify how many rows that each of this data frame has. So you can give n row, which is 150. So remember we used n row in matrices as well, right? To split your numbers into number of rows and columns. We gave the elements n row is equal to some number and col is equal to some number. Same n row is here is we are trying to identify number of rows, and n col is for number of columns. So you want to know the dimension, which you have to just give them. Which means the first element is always gives you the row values, and second element gives you the column values. So it says 150 rows and 5 columns. The class is data frame, as that we know. And when you say the head of iris, it gives you the first 5 values of the data frame. Okay, when you give tail, the last 5 values of the data frame gets printed. Okay, so only the people use this to understand the data. Okay, so you don't have to, for example, if your data frame has 1 lakh rows, you can't do that. And even if you like view it separately here, sometimes it is difficult to go there and check. So instead of that, you can just like give head and tail as well. Okay, and to know column names, you can just give names. What are the column names that you have? You can just give names. Okay, and to identify the maximum value of a particular column, so you can, so for example, I have a sepal length column in the iris data set, and I want to know the maximum value. So you can just give max, which we did already for to identify the maximum value for the volume column in the tree, right? So I'm trying to find the minimum value for sepal length in iris, 4.3. So range, I think you all know what a range is. A range is nothing but the maximum value minus minimum value. So which we can be like found out here. It actually gives you the maximum value as well as the uh, minimum value together. So instead of typing max and min separately, you can just type range. So quantile, it gives you the uh, minimum value as well as maximum value with three different intervals. At what is the 25%, 50% of the value? What is the 75th percentile of the value? And mean gives you the mean value of that particular column. And if it is like kind of in decimals, you can round it off. So for that, you have to use round of mean of average sample length. Median, yes, you can give. So for example, if you're trying to print sample length values, everything, sometimes few values will be repeated. And to find out the unique values only of that particular column, you can just give this. So you can actually, I mentioned earlier, there are only three species of iris has been the data is collected here for, right? So here I'm just trying to find out the unique species here. So I have only three things: Setosa, versicolor, and virginica. Okay, these are in the factor data type. So when you say factor, actually it's like you have only a few different elements which gets repeated, so that you can call as a factor. Okay, so the standard deviation value, actually this will, the standard deviation, mean, median, variance, everything will be calculated only for the numerical values. Okay, if you call them as numerical values, you can apply all this. So in this iris data set, we just have only one column which has string, the species. Other than that, all the four columns has numerical values. So I'm trying to calculate standard deviation for sample length. It's 0.82. Variance is 0.68. Okay, here comes summary. It's a very important feature. For example, when I just give summary, it gives all the column names and minimum values, maximum values, quantile values, mean, median values for each of the columns. So instead of like trying to go and separately finding this out, you can just like give summary iris. So it gives everything. And imagine you don't want all the things. Okay, for example, if you don't want all the things, you just want only for sample length, only one particular column, you can just give summary of iris of sample length. It gives it here. And one thing, if I were to mention, if it is a numerical value, you get all this minimum value, maximum value, median, mean, all this stuff. But if it is a factor, if it is a string, so it gives you the count of each of the string. Okay, so we have only 50 different values, 50 different rows for each of the species. Okay, so attributes, when you give attributes, it gives you the row names, column names, and what is the class. Okay, so here it gives you the column names, the class, which is a data frame, and the row names, which is usually the number. It's 1 to 50. The index is actually your row names. Okay, str iris. So str iris actually gives you the column names, and then how many number of observations are there, and how many number of columns are there. So 150 observations of 5 variables, which means the 5 different columns, 150 rows, and these are the column names, and what is the class of it. So all there's a number and one is a factor, and it gives you the glimpse of few items. Okay, so then there is a function called describe. Okay, to do that, you have to use you have to call a function called HMIC. Okay, I've already, I think I don't have it. So for that, I'm installing the HMIC package. Okay. Okay, I've installed HMIC and I'm calling out. Then, okay, there is a problem here. Okay, so I have to have a lattice. Actually, I've installed and then I've removed the lattice package, right? So I have to install lattice package for HMIC to work. Sometimes few packages are like kind of dependent to each other. Okay. So I installed both HMIC and Lattice. I'm trying to call out the library, and then I'm just giving describe. Okay, so when you give describe, it says 5 variables, 150 observations. It gives the lowest values, highest values, mean, and all the other things, the distinct values, if there is any missing values. Okay, so a lot more other information. Okay, so I want you to do the same thing that you have did for empty cars. Okay, we found out quantile values, minimum, maximum, range, mean, median, unique values, summary, description, everything we did for iris. I want you to work on the same thing for the empty cars data set. Okay, so that you get more um, experienced with these comments. Okay, so now we'll be like looking into few missing values. How can you will be treating the missing values? Okay, okay, so we have x is equal to 1 comma 5 comma na, which means a number, there is a value but we don't know, it's missing. 2 comma 4 comma and another missing value. Okay, so I'm just running this and I'm just checking is there any missing values here. Okay, is na in x, I'm asking, it says false false because first and second value is false but third value is true because it's na. False false and again it's true because the sixth value is na. So the sum of these na is 2. There are two values. So if I want to calculate mean for that, we can't calculate that because we have na values, few missing values, but we can calculate missing values by ignoring the na values. Okay, then we have 3, which means we are ignoring the na values. It will calculate. It will take there are only 4 elements which is present in the x variable, and then it will calculate a mean. Okay, so for example, we are like assigning values a equal to sequence of 1 to 66, which means from 1 to 66 all the numbers will be stored in a variable. Okay, so I'm asking is there any missing values for a? False, because we have the natural numbers 1 to 66, everything is defined, right? Which means there is no missing values. So we are asking the sum of is na. It's going to be 0 because there is no na missing elements, na elements, right? So, sum of is na is 0. And I'm asking, is it a finite number? Is na is finite? Each of the value we are checking is it is a finite number. Okay. So what is sum of finite number? It's a 66. Because from 1 to 66, it's 66. So I'm asking if there is any infinite number. Sum of infinite number is 0. Okay, so we just like dealt with the missing values in a vector. So let's see how we can deal with the missing values in a data frame. Okay, so I'm assigning 1, 2, 3 for x. For y, I'm assigning 0, 10, and a missing value. So with this, I'm merging these two vectors and creating a data frame, which we have discussed earlier, right? So I'm creating a data frame and I print it. X has 1, 2, 3, y column has 0, 10, and na. So and I'm trying to omit the na values in a data frame and print it, which means I have only 1 and 2 in x, 0 and 10 in y. So when I'm trying to omit na value for the y variable here, y column here, what happens? The 3 from the x is also getting omitted because it belongs to the same column. Okay, so this is how it happens. So you can also like do some graphical graphs here. So I'll just show you how things work, how a graph looks like here. In the next session, we'll be like looking especially on how you can do graphical analysis using R. I'll just show you how we can just do a plot. Okay, so here I'm just plotting the sample length of iris data set. Okay, so here there are 150 entries. So I have the y values as sample length and the index number is my x value. So this is my scatter plot. So you can also do a box plot here and understand how it is being distributed. Okay, the majority of the values are between 1.5 to 6.5, I guess. Okay, and then we'll look into what is an apply. Okay, so we have A is equal to 16 to 8, which means from sequence from the number 16 to 8, which is in the backward 16, 15 until 8, we are assigning to A, and for B, 20 to 19, and then 6 to 12. These two sequences are assigned to B. Okay, and we are like kind of binding this C bind. C bind means you can also like use C bind or a data frame. See, here we are using data.frame. You can also like use data cbind, which means which merges two columns. Okay, here you can see both column A and B is variables are kind of merged, and you are able to get a data frame. You can do this like this as data with two different types, data.frame or cbind. Okay, so here what I'm trying to do is with this data set 1, I'm trying to calculate the mean. So if you want to calculate the mean by row, okay, for each of the row, you want to compute mean. 16 plus 20 is equal, the mean of 16 and 20 is 18. So if you give apply data set, margin equal to 1, mean, you get the mean gets calculated by row. If you give margin is equal to row 2, the mean gets calculated by column, which means you will have only two values. Okay, for this column, the mean value is 12. For this column, the mean value is 7.33. Okay. So I have a task here for you, which I want you to calculate the mean for all the variables in empty cars data set. Okay, by using this apply function, do that. Okay, for all the variables. Okay, instead of data set 1, you just have to give empty cars. That's all. Which I have it here. I'm not going to run it for you. You have to do it. I just gave margin equal to 2 here, but you can just mention 2 or 1. Okay, don't have to type margin. Let's see how we can work on manipulation in list. Okay, so I have a sequence 1 to 4, and I want to do x square. The function is x square. Okay, so when you give that, so we'll get the output in list. That is L apply. Okay, so 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So we're getting that in a list. Okay, so L apply is list apply. We are applying the output as a list. Okay, so we can do this as well here. So for computing the mean of empty cars, you can also do this here so that you will get the value as list. Okay, like this. But when you do it like this, just apply, you will not get that. Okay, so I can just show you. Here you're getting it as just a numbers, but here you are getting it as a list. Okay, so here I'm trying to add +5 to the MPG column in empty cars. Okay, so the different columns, I had an MPG column, miles per gallon. So I'm just trying to add, so all the 32 variables which been added 5. Okay, and we are getting the output as list. If you don't have, okay, this function, all the functions will work only with L apply. Sorry. Okay, and then we have, if you want to list it in a vector format, you have to use S apply, which is nothing but simplify apply. Okay, here the same thing in the L apply we had. If you give L apply, you're getting the output in list, and if you're giving S apply, you're getting a simplified answers in a vector. Okay, all the same thing we are doing it here. Okay, the x squared. If from 1 to 4, I'm doing the x square, you're getting it in the as a vector. Okay, when you give simplify is equal to false, you will get it as in a vector format. Right? So here simplify F is doing the magic. In default, simplify is true because it's S apply. Okay, and there's a T apply, which means you will be getting the answer in table format. For example, I'm trying to calculate the mean for sample length and species for in T apply, which means I'm getting the mean for Satosa, the sample length for each of the species. For example, for species wise, I'm getting the mean. For setosa, the sample length mean is 5.006. For versicolor, the sample length mean is 5.9. Virginica, it is 6.5. And the same thing I'm doing it for petal length. For T apply, you have to give 2 columns. Because for each of the species, I'm calculating the mean of that particular variable. You got any questions, guys?